This week on the show, we cover the FreeBSD second quarter status report of 2020. The traditional Unix toolchain blog from Warner Losh is interesting to us. That's why we read it. BastilleBSD got a release of 0.7, and we talk about what's in there. Finding meltdown on DragonflyBSD is a short item that we have, nevertheless important, and more in this week's episode of BSD Now. BSD Now, episode 363, Traditional Unix Toolchains. Recorded for the 12th of August 2020. This episode of BSD Now is brought to you by Tarsnap. Go to tarsnap.com for your online backup for the truly paranoid. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Welcome to this week's episode, everyone. We have some interesting headlines for you, so we should get right into it. The FreeBSD Quarterly Status report is out, and we should look at it.
Yes, there's reports from all the different teams, including the FreeBSD core team, release engineering, cluster admin, continuous integration, ports manager, and the FreeBSD Foundation, plus the actual quarterly status report team themselves. And I snuck an entry in there for FreeBSD office hours, which is becoming a pretty regular thing. If you're interested in that, you should be checking those out. So these are generally scheduled a bit ahead of time, and they are 1 hour online video meetings that everyone's welcome to join in and ask their questions about BSD to whatever random developers happen to show up for office hours. I guess we've done 8 of these so far. Well, yeah, 8 full office hours plus 1 bugathon. And there's another bugathon scheduled for September 19th. That's giving everybody plenty of notice because generally, you're going to want to block up most of the day for the bugathon. And so you should check that out. And also, if you have ideas on topics and so on for future office hours, please do get in touch and let us know.
Yep, this is for the community, with the community, and the people asking questions on the channel are the ones that make it actually happen. Because if no one asks questions, this is a very boring session then.
Yeah, basically we've done 4 general Q&A sessions, 1 specific session about the FreeBSD Foundation, 1 session before the core team election with all of the candidates, and since then 2 sessions where the core team has held a town hall to let members of the community ask core questions and talk about some of their plans and so on. And I think sometime soon the Git working group will be hosting a session to answer questions about the migration to Git as the repo of truth for FreeBSD.
Ooh, exciting.
Yep. So after the team reports, there are the project reports, including FreeBSD on Microsoft Hyper-V and the Microsoft Azure cloud. Oh, there it is. A status update from the Git migration working group, led by Ed Mast, Warner Losh, and Ulrich Borland, who are working out the details of how to move the FreeBSD project over to Git, and all the people in the working group there. There's a report about the expanding usage of Lua, the scripting language in FreeBSD, and especially FLua, the special FreeBSD derivative of it that'll be available in the base system for people to build things that are, more complicated than what you normally want to do with a shell script, but maybe not as heavy duty as something that needs to be written in C. There's also updates on the Linux compatibility layer and the project to add TLS support to NFS in FreeBSD. So this will basically allow FreeBSD to meet a new RFC draft for NFS with encryption. And it will use TLS 1.3 to encrypt all data traffic on the Sun RPC connections used by NFS. And this will even make use of the accelerated kernel TLS support that Netflix added, but we'll also need to build the part of that for the reverse, basically to receive encrypted data quickly, not just send it. There are setup instructions if you want to start testing with it, linked in the status report. Then under kernel, there's a bunch of projects, including an audio framework and more audio drivers for like single board computers, Beehive NVMe emulation. So this allows Beehive's virtual disk to emulate an NVMe device instead of an old-fashioned hard drive, which can give you much better performance because it can take advantage of multiple queues and so on. Updates on Bluetooth on the DRM drivers. So that's the Intel and AMD graphics drivers. DTS updates, the FreeBSD ENA, or I think that's Elastic Network Acceleration or something like that. It's the Amazon high-performance network driver for the cloud, forcibly unmounting UFS and FFS systems when a disk fails, and improvements on that. i.mx8m support, which is another I think ARM-based system. Updates on Intel Wireless and support for 802.11ac. So if you're interested in Wi-Fi, that's getting better. AMD 64 5-level paging structure support. This basically will allow AMD 64 machines, which currently use 4-level page table structures, to support up to 48 bits of address space, to be able to use 5-level paging structures, which allow for 57 bits of virtual address space, which will allow 512 times more virtual memory on FreeBSD machines. So that will be quite interesting, especially since that much virtual address space makes lots of interesting things possible. There's also work on non-transparent superpages, being able to explicitly request large superpage mappings. The NXP ARM64 single-board computer support, AMD 64's PMAP fine-grained PV list locking for improved performance, lockless routing lookups and scalable multipath improvements, integrating Z standard compression into ZFS, and an update on CherryBSD, which is the secure CPU, secure pointer version of FreeBSD that's being developed in part by Cambridge University. Very interesting stuff. There's also architecture updates, including the RISC-V port and update on continuous integration for platforms other than the normal x86 stuff. Improvements in userland, including replacements for the BC and DC math programs, replacing the old bin utils, updating the runtime dynamic linker, and VHDX support for MKImage. So using the MKImage tool to be able to create, I think that's the Microsoft Hyper-V virtual disk format, the extension of the old, what was the old Microsoft virtualization called? Virtual PC, the VHD. So VHDX is the extended format that supports up to 64 terabyte files and is used by newer versions of Hyper-V and Azure. And so support for that is built into the tool on FreeBSD you can use to make disk images. Then for ports, there's Bastille, the jail manager, which we have another story about later in the show. Updates on KDE and Haskell. RTSX, porting a driver for the Realtek SD card reader from OpenBSD as a port. And updates to Valgrind, basically a program for looking for memory errors like use after free or memory leaks and so on in your applications. And it had, because of the way it overlays the system, it had some problems after all the changes in FreeBSD 12 for the 64-bit inodes and so on. I needed some work, but somebody's finally managed to get around to that and done the Herculean effort of getting Valgrind all up to date on FreeBSD. So you should check that out if you're do any kind of development. Then under documentation, there's status report on the various translation projects and using WebLate to be able to translate the FreeBSD documentation a lot less manually, which is improving the quality and up-to-dateness of the translations. Then there are miscellaneous updates, including one from Freshports on how they're going to handle switching over to Git and so on, and some of the other changes and what they're looking for help for. Then there's PCI pass-through into Beehive on Intel when using AMD guests, and there's some work on that. And then finally, there's an update for SageMath. It's a free open source mathematics software available under the GPL. It builds on top of existing things like NumPy, SciPy, Matplotlib, and a bunch of other tools, and the R programming language and so on. And so that's a work in progress that will soon be available by the look of it, and giving you a viable open source alternative to things like Maple or MATLAB.
Nice.
Then there's also ChiFi, which is a text user interface for managing Wi-Fi networks. Basically make WPA supplicant not something you have to edit by hand anymore. And it's named after chai, the tea. So it's like, how to join coffee shop Wi-Fi and so on. There's also Mixer TUI, which is basically designed to provide a text user interface for your audio mixer, and Potluck, which is a flavor and image repository for Pot, the jail/container management tool.
Yeah, that's all the reports in summary. You should definitely check out the details, and because many of these items may have a section called Call for Help or where you can contribute something, and it might be your first step into the open source world, for example. And you can see by the different categories, it's not just code writing, it's also translations and documentation or other bits and pieces where you can get your first feet wet in the open source space.
Yeah, and some of the stuff, even the stuff that's not directly FreeBSD. For example, Dan's got some bits he could use help with on FreshPorts, where it's just some basic web programming. You don't have to be a systems developer, but if you've you can help them with the CSS to make certain parts of the page look better, or writing a little bit of PHP to parse the output that he gets from the package tools and be able to put it in his Postgres database and so on. There's lots of stuff, or even just a little bit of JavaScript help that he was looking for help with.
Yeah, so check out the full report, and thanks for the people who helped compile it. All right, then.
And I guess congratulations to Daniel on getting a FreeBSD documentation commitment.
Oh, yeah, just recently. Yeah, he wrote the report, and you can see the people who are doing too much work are getting punished eventually with a commit bit. People never learn. Moving on to the next item. Traditional Unix toolchains over at Warner Losch's blog. Warner we had interviewed last week, so that was interesting. And he keeps blogging, and this item here caught our attention. The traditional Unix toolchains is the title of this blog post, and goes like the following. All the Unix systems tend to be fairly uniform in how they handle the so-called toolchain for creating binaries. This blog will give a quick overview of the toolchain pipeline for Unix systems that follow the version 7 tradition, which evolved along with Unix, a topic for a separate blog maybe. Unix is a pipeline-based system, either physically or logically. One program takes input, processes the data, and produces the output. The input and output have some interface they obey, usually text-based. The Unix toolchain is no different. Here's a little illustration how that works. The C compiler takes the C code and turns that into assembly or assembler code. How it does that and how it optimizes, etc., is for another blog post. So that's a whole lot more involved. Once the assembler is created, it passes to AS, which translates to the assembler into .o file, which is the object file, containing the binary representation for the assembler, plus a lot of metadata about it. What addresses correspond to what symbols, how to relocate the raw assembler when connected together, various debugging information, and sometimes what section each bit of data resides in. So you cannot directly execute a .o file, which you probably tried and didn't go very far. LD takes all the .o files and produces an executable, the default name, which is a.out. Not very creative, but that's how it is. A.out files are executable. They happen to be in the same format as the .o files, except they have a different magic number, which tells the kernel how to load them into memory and initialize the CPU registers for that program. Then there's a section about program layout. There's a text data, data section, BSS section, and a heap, so that the program can allocate dynamic memory and shrink and grow, and depending on how much data you feed into the program and demand paging and stuff like that. Yeah, so for the PDP-11 in this case and other segmented architecture, there can be complications. There can be separate IND space, instruction and data, so that each one resides in its own address space. This helps the PDP-11 programs break into the 64K limit. In addition, there can be overlays, right. In addition, there can be overlays. There are 8K segments that are mapped into the address space as needed to increase the text size of the program. The linker handles much of this, but the programmer must specify the overlap groups. Each group can be more than 8K in size, and the main program can be no more than 56K in size. And the overlay manager uses 8K of the data segment as well, so it's not much. Programs in Unix tend to not use the overlays, but the kernel makes heavy use of them. Then there are sections about the compiler, the assembler, and the archive files, all going into very details about how this all fits together. Then there's a section on the loader, the kernel, And yeah, all of these bits are quite interesting. Bit long read, but definitely worth watching. And the conclusion goes, without the complications of shared libraries or link time optimization, the tools of this area tended to be rather simple. They had simple interfaces between them. There were good boundaries between the different components. This limited the number of programs with knowledge of the formats for the different layers, but due to this limited spread of knowledge, switching out different parts for other parts could often be done without changing components that didn't directly know about the object format. This also produced simpler programs that used different engineering tricks to get the most performance out of the limited hardware of today. The PDP-11s were approximately 0.1 to 0.5 MIPS machines in this time frame with super slow I/O paths. This was about 100,000 times slower than most computers people interacted with today. One advantage of the thoughtful engineering trade-offs is that all the pieces are relatively easy to understand. And the modern ecosystems that we have today are more complex. Oh yes, of course. ELF came along in the 90s and obsoleted the text data BSS worldview from above. The shared libraries made huge programs like X11 feasible. Today, the Clang, the C language compiler, the whole toolchain, bypasses the separate assembler stage and generates .o files directly. The LLVM linker, LLD, can optimize binaries between modules to produce better code. All of these new features added complication to a simple model. While I mourn for the loss of simplicity, I've become too used to the rich features they provide to want to go back. Understanding the roots of this complexity, though, helps to understand some of the weird quirks that persist, even to this day. Oh, and speaking of weird quirks, I'd like to end with BSS. It's a 1950s IBM assembler mnemonic for block started by symbol, and was used to create storage that was associated with a symbol, but had no initial value. Today, BSS is no longer that, exactly. Its origin has been lost for most people in the sands of time, and now it just means zeroed storage area. So this very Unix-centric term actually predates Unix by 10 or 15 years for a machine that Unix wouldn't run on until it was 10 or 15 years old. There's a snapshot here in the blog post from the IBM assembler manual so that you can see a bit more details. And yeah, this is another interesting history tidbit from Warner Losh, and I think there will be more coming in future blog posts. All right, it's time for the news roundup in this week. We have Bastille Day 2020. Oh, that sounds interesting. Version 0.7 has been released.
Yes, basically to celebrate the holiday, the people that make Bastille, the jail manager tool for BSD, have released version 0.7.x. So they say this release matures the project into the 0.7 branch. Continuing testing and bug fixes are proving Bastille capable for a range of use cases. New experimental features are examples of innovation from community contributions and feedback. So they have a new Bastille file template syntax, now allows for more flexible automation by allowing template hooks to be used in any order. So they kind of show how you can run a command, copy a file, install a package, set a setting, or whatever. This feature and syntax is new. Please report any issues using the GitHub issue tracker, and also see the README file for more information on how to use them. They've also created experimental empty container support. This feature allows creating an empty container, allowing you to try creating Linux containers. So when you create it, it will be completely empty rather than default populated with a version of FreeBSD. Your mileage may vary. Use at your own risk. Did I mention it's experimental? They also created mount and umount subcommands to allow you to manually mount a template or whatever to be able to work on it. And then general improvements, the Bastille template subcommand now uses the native subcommands to execute for automation. This makes the code more reusable and is much appreciated community contribution. And they have some other bug fixes like the Bastille logdir being set by default, and they added support for a vagrant file and added deduplication for fstab entries to avoid making multiple entries for the same thing.
That helps, yeah.
But it's good to see that there's a community growing up around that tool and lots of external contributions.
Yeah, people seem to pick this up and, yeah, as Alan said, contribute their own bits. And yeah, we will watch this closely and see where it grows into. All right, it's time for Beastie Bits this week. We found a couple things on the web, but if you have found something that we haven't covered yet, then you should send this to us so we can cover it here for everyone. Your link could be just a simple thing, could be sent to feedback@bsdnow.tv to appear in a future episode. This one is finding meltdown on DragonflyBSD over at the DragonflyBSD Digest. It's really the meltdown fix for Intel. That's not too bad to have, definitely. You now will see it noted if the fix is present during the Dragonfly boot process. So they marked that up so people can see.
Yeah, so basically during the boot process, it will explicitly tell you whether the mitigations are enabled or not. This was suggested by a FreeBSD developer, MJG, when he was doing some benchmarks comparing FreeBSD to DragonflyBSD, and on Dragonfly wasn't able to tell for sure whether the mitigations were enabled or not. And since those impact his benchmarks, he wanted to be able to be sure that he was testing with and without. And also made it default to displaying the CPU features 2 and features 3 fields, so that all the flags, features supported by your CPU are displayed as part of the boot process now.
Okay, that's good to know. Then we have news from the NetBSD project. There's a bit of an outage, but NetBSD wouldn't be NetBSD if they couldn't help themselves with all the hardware that they have.
Yeah, so there was a data center outage of some kind that took out the NetBSD website, but you could still access the website by going to de.netbsd.org, which is a mirror that happens to be running off an Amiga running NetBSD.
And people, of course, asked, hey, what kind of Amiga this is? And follow up, they mentioned that it's an Amiga A3000 with 86060 accelerator card.
A 6860 accelerator.
Yeah. A Cyberstorm MK2. So for people who know what that is or have been around to know, that's available and is running happily. And people even mentioned page loads faster than most React apps. So you never know if you can dust up this old machine that you have in your attic or somewhere in the garage and make it to some good use. Very cool. And I'm sure that the outage won't last long, so NetBSD should be back up.
Yeah, it's already back up.
Cool. This week's episode of BSD Now is, of course, sponsored by Tarsnap, the online backup for truly paranoid people. Remember when you've made your last backup? Was it last year? Hopefully it wasn't. Hopefully it was like 5 minutes ago. That would be better. And while you're doing a backup, you should do it properly. Securely, of course, but also in a way that you can get your files back. But only you are the person who should be able to do that, not someone else who can drag them from the internet or from the backup solution. And that's what Tarsnap does. It gives you a way to first encrypt your data that you have locally on your disk before it puts them out on the storage media. In this case, it's the AWS cloud. And of course, you are the only person who can get back your files because you're the whole key holder to the safe stored files in the cloud.
Yeah, so go to tarsnap.com/bsdnow and look at getting signed up. It's pay as you go, so you only pay for the megabytes that you actually back up, and that's after the compression and deduplication. So you're, it's as cheap as it can be.
And you can save a bit of disk space if you're not backing up the gigabytes of videos that you have, of course. But if you have mostly text files that can be deduplicated or duplicated very well, that's a win for you. And you're saying, well, it might not be running on my machine. Well, you might be wrong in that because it's available for the BSDs, the Linuxes, the Mac OSs, the Cygwins for Windows, and even the Windows subsystem for Windows itself. So there's no excuse for not using it.
Yeah, I even just saw a tweet about somebody trying to get it to work for Android.
Yeah, you might want to back up those machines and those files as well. So you might as well get a solution that works everywhere and you don't have to relearn a new backup solution each time. All right, it's time for feedback and questions this week. Everyone is welcome to send them to us and we try to answer you if it's BSD related or computers a little bit wider. Your questions should go to feedback@bsdnow.tv and then will appear in a future episode. The first one that we have is Vincent with a GNOME 3 question. Here goes. The official FreeBSD webpage for GNOME 3, which is freebsd.org/GNOME, was last updated on 14th February 2016 when there was an announcement for version 3.18. As of July 2020, Freshports showed that version 3.28 is in ports, which was last updated in August 2019, which is much newer than 2016. The last GNOME 3 release announcement was for version 3.36. The FreeBSD port is lagging 4 releases behind the current GNOME 3 release. I was wondering if this particular FreeBSD project had died quietly. I wouldn't be surprised if it had, because GNOME 3 appears to be more tightly coupled with systemd and /Linux with each new version. I think it is time for me to pick a new desktop environment.
Yeah, so the website is just in a sorry state for that, and that page probably should just not exist since it doesn't get updated. The port, yeah, I guess it's getting to be a year out of date now. I'm guessing it's because there's a blocker. I don't actually know. I've not ever really been a big user of the GNOME desktop environment. I know that the KDE one is very actively maintained and used by many people, and I've been using Lumina for quite a while and been happy with that.
Yep.
But yes, I assume there's some kind of blocker that's the problem for GNOME itself, but I don't actually know the specifics of what the
I would recommend you, before you jump ship, to contact the maintainer or the team and ask what the latest version is, or what if you can help somehow, because they're probably also looking for people to test new releases. So that could be a thing before you have to relearn a whole new desktop environment and set that up to the way you like it. And maybe you can get an almost finished version to test and see what the newer version looked like on FreeBSD. That could be an alternative to waiting a little bit longer and getting your desktop back that you know and have used for a while. But yeah, I agree. This page could be updated, or should at least.
Somebody else asked me about it on, I think, in the FreeBSD docs chat room, and I was like, yeah, I feel like we should almost delete that page and make it a redirect to Freshports or something. There are a couple of those old project pages, and they are not helpful. I think they're, in fact, actively harmful because of the
wrong impression.
The fact that they don't get regular updates.
They used to have more regular updates on these status pages, but as people got busy and other people came in and people switched out of the teams, they kind of neglected that a little bit. So we'll probably clean that up a little bit in the future.
Yeah, like the port is from when FreeBSD 12 wasn't released yet, and so on. It's
check Freshports. It always has the latest. Or in your system, update your ports tree or the package and check the version that you get from this way.
Whereas the freebsd.kde.org page has very up-to-date information.
Okay, so that might be your new desktop environment.
There's like an update every week by the look of the newsfeed there.
Remember, this is all volunteer work, and people sometimes have less time than they want to spend on this, and not many people are helping. So if you want to keep this thing going, then offer a little bit of help, and maybe that goes a long way of making it more current to the latest version. Nevertheless, thanks for the question, and hopefully we gave you a couple pointers and help. Next up is Hassan with a video question. Hassan asks, or wrote, I run ZFS on my laptop, and I would like to keep a complete backup of the storage in case it ever breaks. I already back up my home directory to an external machine, but I'd like to keep the full backup on a portable hard drive as well. I'm wondering what the best way to do this is. Should I add the portable HD as a mirror and run it degraded whenever I don't have it plugged in, and just let it resilver update to the latest? What would be the restore procedure?
That's one option, although that's possibly a bit more work than making it a separate pool and just using ZFS replication. And ZFS keeps a dirty log and would be able to catch the missing mirror up sometimes. Although I think once it's more than so far behind, it will just do a full resync, which will take longer. So replication might be slightly better, and also means that you have slightly less risk of, if something goes wrong with the pool, that you won't be able to restore the backup.
Yeah. I just noticed that this question was not from Hassan, but from Malcolm. I switched those two. Sorry about that. So Malcolm asks this question, and the sub-question here was, what would the restore procedure look like? If I'm doing a new FreeBSD install, would I just drop down to a shell and add the new laptop as a mirror and resilver it over?
So yeah, basically, once you plug the USB portable hard drive in, if it's a replica, then you could just send it back to the machine. Or if it's a mirror, you can just boot off of the USB drive and use that copy of it. And then yeah, you could add your real hard drive as a mirror and eventually remove the hard drive, the SSD or the external drive from the pool as well, or degrade it again, kind of thing. But again, ZFS replication is probably slightly easier. And so what you would likely do is just do a fresh install, and then at the very end, while still in the installer, in the little shell you can get at the end, you could then ZFS send from the external hard drive onto the main hard drive and overwrite the system that you just installed with the contents of the external drive.
Mm-hmm. And the third question is, I never feel comfortable adding the boot code when I upgrade ZFS, and I assume I would need to after the resilving is complete to be able to boot again. Is that correct? Is there an easy way to think about adding boot code that I can feel comfortable if I'm not overwriting actual data?
The gpart bootcode command is the right thing to use to install the boot code, and the only thing you really have to watch out for is when you're doing the command, there's a flag -I that tells it which partition to put the boot code into. And you want to make sure that that number corresponds to the correct partition. On most of your systems, it'll be 1 or 2. So you can do gpart show, and it will show what the partitions are. And you want to put the boot code in the one that's FreeBSD-boot if you're booting legacy, or the one that's EFI if you're booting with EFI. Although with EFI, you update the boot code a little bit differently now. We don't just splat a small image in. It's actually a FAT32 file system that you can just mount and update the one file inside of it.
Yeah, that should do it.
There are instructions for that somewhere, although we need to make that easier to find.
Yeah, but it's true. Each time you upgrade your ZFS code, it needs to write a new boot information to the boot blocks so that it actually knows about the new ZFS format internally and how to make things happen. But yeah, thank you for your question. Sorry for the mix-up. And yeah, hopefully that gave you a couple of help with your backup strategy. It's a good strategy so far, using ZFS, of course. And yeah, hopefully you'll never have to restore in a case of catastrophe. All right, now comes Hassan with the video question. BSD Now crew, I've been a fan for a while, since way before you went under Linux Academy. Oh, that's a long time, yeah. I've stayed a regular listener as I've worked my way over to BSD as my primary computer. Okay, that sounds encouraging. I don't need to see you guys, but occasionally when you are referencing a website or something, it would be nice to have a video to look at. I haven't found video anywhere for BSD Now, which used to be on YouTube. Is there a way I can pay for video? Or do you just not do that anymore? I remember looking around when the video stopped on YouTube, and I don't think I ever heard you guys on air say that you weren't doing video anymore. So I'm confused. In any case, I love the show. I learned a ton, and I'll continue to support you, video or not. Oh, thank you. That's nice of you. I will be sending technical questions in the future. Excellent. But right now I'm busy with graduate school. Oh, good luck with that.
So I think we're slightly spoiled now. I don't know that we would bring video back. Production is much easier without video, and in particular, especially because Benedict and I do this remotely, and he being in a different continent than me, there's a high latency. With audio only, we can edit around things a lot easier, or just, if we both happen to speak at the same time, we can time shift it so that we suddenly didn't speak at the same time, which doesn't really work with video. And it's just much easier production to do without video. But there's always a possibility that we will do video again in the future. We do actually have a YouTube channel again that has our show, although it's basically just a visualization filling in the video with the audio only. But if you were struggling to find BSD Now on YouTube, we have a link to the new one. We'd appreciate it if you subscribe, because we need about another 100 subscribers in order to get a short URL for our channel instead of being a bunch of random letters.
Yeah. And yeah, everything that we talk about in the show is linked in the show notes, and you can just go from there from a central point. And yeah, sometimes when we mention something, oh, look at this picture here on the website, it's kind of not helpful in the audio only format. But we try to avoid that because we know this is a different format now and people cannot actually see what we're talking about. But definitely thanks for the feedback, and we welcome, of course, your technical questions as well. It could be any kind of question, doesn't have to be technical. But if you're getting stuck somewhere and need a bit of BSD help, then we're definitely here to answer that. All right, I think that pretty much wraps up this episode. Thank you for listening, and definitely provide us with feedback at bsdnow.tv as always, and then we'll listen Well, you listen to us. We don't listen to you usually. we talk, you listen. Next week on BSD Now.